Alright, let's look at the practice exam 3, problem number 3. Alright, so we want to sketch the graph of f of x equals x e to the negative x. Alright, by answering the following questions. Alright, part A, find f prime of x and the critical value of f of x. Alright, so let's do that. Alright, so we need to take the derivative, but looks like you have two things multiplied together. So we're going to use a product rule. F prime of x is equal to, derivative of the first guy is 1 times the second e to the negative x. Alright, plus first guy times derivative of e to the negative x. So e to the negative x times negative 1. Right? So if you combine that, you're going to get, looks like 1 minus x e to the negative x. Right? So this is the derivative. Right? To find the critical number, we set this guy equal to 0. And you can see that x equals 1 is the critical number. Critical value. Right? And part B, we just take another derivative. So you have f double prime of x is equal to, right, now this is the first guy, this is the second guy. Right? Derivative of the first guy is negative 1 times the second guy, e to the negative x, plus first guy, 1 minus x, times derivative of e to the negative x is e to the negative x times negative 1. Right? So what we'll get is, let's see, negative, let's see, we're going to pull out the e to the negative x. Right? Then looks like you have a negative x, so plus x. Right? Oh, maybe I'll write it this way. Right? Plus. Right, so plus x. Right, so here's a here's a negative 1, and then you have another negative 1, so it's going to be minus 2. Right, so we have that, and the inflection point, you can see that this is going to actually, we're going to set that equal to 0, then x equals 2 is the only possibility. Right. So we want to make sure that this is going to be the inflection point. And if you want to do a number line, it's pretty clear that here is x equals 2. And this is f prime, double prime, sorry. Then you can see that if you plug in anything less than 2, so like 1 minus 2 is negative, so this is going to be negative here. And we can try x equals 3, and 3 minus 2 positive, that's positive. So you have a positive. So you have a concavity change at the x equal 2. So at that point, you're going to have an inflection point. So all you have to do is find the f of 2, which is equal to 2 e to the negative 2. Right, therefore, inflection point is x value is 2, but the y value is 2 e to the negative 2. Right? So that would be the inflection point, and this is the second derivative. Alright, so based on part A and part B, let's complete the sign there. Alright, so let's look at, actually we did for the second derivative. So less than 2, so here, it's going to be negative. So we put the negative sign here, and a negative sign there. And after 2, you're going to have a positive sign for the second derivative. Alright, how about the first one? So we have critical number is at 1, right? Then if you're looking at the f prime, you can try anything smaller, so smaller than 1. So like I try 0, and we're going to try 2. So if you plug in 0 in here, 1 minus 0 e to the negative 0. So that's going to be a positive value here, right? If you plug in 2, 1 minus 2 is negative, e to the negative 2 is positive, so the entire thing is negative. Right, so we know that here we have a sign here, right? So if it's less than 1, it's positive, and if it's greater than 1, it's all negative. So negative here and negative there. Alright, so that's the find the interval on which f is decreasing and concave up. So we're looking for f is decreasing, so which means that first derivative is negative, right? At the same time, and it's concave up. So you can see that this is the only interval here, right? Decreasing and concave up. We want decreasing and concave up. So that's the interval there. So interval, so f is decreasing and concave up on this interval from 2 to positive infinity. Right? Then use part A through part B, D to sketch the graph of y equals f of x. Right? So let's sketch that. Right, so we have x-axis here and y-axis here. Right. Then let's look at this original function. Let's say it's going to go through origin. So because if you plug in x equals 0, it's going to be 0. So you're going to go through this point. Right. And a critical point is at 1, and the inflection point is at 2. So I'm going to mark those. All right. F of 1 would be 1 times e to the negative 1. So e to the negative 1 is right, let's see here. All right. So it's not the correct scale, but e to the negative 1. All right. Then you have to go through here. Right, and also inflection point is 2, 2 e to the negative 2. So it's going to be smaller than e to the negative 1. 2 times e to the negative 2, and you have an inflection point. So I'm going to just put a dot there. All right. So going through those points, and then we have to follow this shape. Right, so increasing and concave down. So we know that the graph should look like this, increasing and concave down. Right, and after that it's decreasing and concave down. So here it's still decreasing and concave down, and after that it's still decreasing and convex up. Right. Then you can actually have a horizontal asymptote at y equals 0, or the x-axis. Right. So this is the graph of the original function f of x. Right. That's it. I hope that this was clear.